Hi friends, myself Gambhir from Computer Science and Engineering. I am going to talk about a new topic called the 8 puzzle using A-star algorithm. In the real world, as we know, the puzzle we have solved in many ways, like physically and by newspaper and many other ways. Now let us talk about the objectives of the 8 puzzle algorithm. The objectives are, there are two objectives. One is the to reach the goal state. What is the meaning of the reach the goal state? From initial state to the goal state, what is the sequence of valid moves? Then comes the minimum solution, where we have two methods in it. One is the minimum number of moves. To move from initial state to the goal state, the sequence number of moves where it has taken to move from one particular state to another particular state is the minimum number of moves. Next comes the efficiency. What is the efficiency? The efficiency is that to move from an initial state to the goal state, how much number of efficient ways as it has taken to move from one state to another state, where it is more efficient. Then comes the main important topic, what is the 8 puzzle problem? What is a 8 puzzle problem? It is a new method where a 8 puzzle is a sequence of slides which contains 8 number of blocks, and it is in a 3 into 3 grid where it contains a single blank space where the number are at 1 to 8 and the ninth box is empty, where we initialize a particular initial point. The rules are simple, where we move the particular slide to an empty space, where the rules are to move from up to down and left to right, where it cannot move diagonally and it cannot skip a particular slide. Now my friend Rahul will explain about the heuristic value and A-star algorithm.
Yeah, my friend Gambhir discussed about the basic approach of the eight puzzle problem. So now let us discuss about the heuristic search and search technique and the algorithm used for the eight puzzle problem. So starting with the search technique, we use the heuristic search technique, which is also known as informed search technique, because we we need information about the girl state since the beginning of the problem, and the heuristic search used to generate the heuristic value based on the goal state and the current state of the problem. So there are some of the example of heuristic search are tree at A star tree search, A star graph. Going with the algorithm, we use the A star algorithm because it is widely used in pathfinding and graph traversal techniques. The main key feature of A star algorithm is it keeps track of each and every visited node, ignoring the node already visited. It make use of two lists called open list and closed list. Initially, starting node was kept in the open list, and its adjacent nodes are all traversed. Once they are traversed, the node which is present in the open list is transferred to the closed list, and the adjacent nodes are stored in the closed list, and they are traversed like that until we find a optimal path. So for finding the optimal path, we use the formula f score is equal to h score plus g score, where h score is equal to heuristic function and g score gives the values between the initial node and the current node. By summing up the heuristic value and the g score, we get the f score, which gives the optimal path for the traversal between 2 points. Thank you.
So as Rahul said, the basic function here is the number of nodes displaced from his original position. So let's solve a problem. The initial node of the problem, initial stage of the problem looks like this. That is 1, 2, 3, blank, 4, 6, 7, 5, 8. So the blank space here can be moved up, right, or down. So taking all the cases, the first step is moving up. So as we move up here, 1 is displaced from its original position. 2 and 3 are in correct positions. 4, 5, and 8 are displaced. So total is 4 displacements, but the number of moves is 1. So total function is number of moves plus heuristic function, that is 5. So the next case is moving right. So if we move right, 1, 2 and 3 are in correct position, 4 also is in correct position, but 5 and 8 are displaced. So heuristic value is 2, number of moves is 1, so total f is equal to 3. So similarly, if we move down, we get heuristic value as 4. So 1 plus 4 is equal to 5. So comparing these three cases, the first case f is equal to 5, second case f is equal to 3, and the third case f is equal to 5, we get the minimum value if we move the blank space right side. So that is f is equal to 3. So continuing this the problem in this direction, we get 4 possibilities now. The blank space is in the middle, so it can move up, left, down, or right. So if we move left, we will return to the initial node. So we won't move left. So the remaining 3 choices is down, right, and up. So let's take down first. So if we go down, 1, 2, 3, 4, 5, 6 are in correct position, but only 8 is displaced. So h value will become 1. 2 plus 1 is equal to 3. So total value of this node is 3. So the next case is blank space moving right side. So if the blank space moves right side, the total displacement will be 3. That is 6, 5, 8 are displaced from this original position. So total g is equal to 2, h is equal to 3 becomes f is equal to 5. Similarly, solving for the third node, we get h is equal to 3. The total is total as f is equal to 5. So considering the minimum node here, we get that is the first node is the minimum one. So we get 1, 2, 3, 4, 5, 6, 7 blank 8 as the resulting node.